Assalamualaikum and good day everyone. I'm Muhammad Akmal bin Sheikh Maidin, currently pursuing Master in Computer Science at MSU. Today, I'm going to explain in detail about my paper, which is a study on medical image compression technique based on Huffman coding and discrete wavelet transform. Introduction. Compression of an image is a method, technique, or process applied to an image that aims to minimize the size of the image and eliminate redundancy so that the image can be stored or sent very efficiently over the bandwidth of the internet. Image redundancy information must be compressed to achieve the purpose of the image compression. This compression can be done with any image format using any available method. There are two types of image compression, which is lossless and lossy. Lossless compression. This lossless compression technique is a way of generating image compression. This technique decompresses the compression data and keeps it the same size as it was before compression or the original data. This technique ensures that the image does not lose information due to compression. This technique is generally used for medical professionals. This technique is required when the user wants the image to be the same size after the compression and decompression process are complete. The GIF format and the PNG format is the example of this technique. Lossy compression. This lossy compression technique is another way to generate image compression. This technique compresses and changes the details and change the color of image become easier than the original image. This allows you to reduce the size even further without affecting the image. This technique can make the file smaller than lossless technique and continue to be used until now. This technique usually removes useless data from the image so that the resulting image does not stray too far from the original just by looking at it with our eyes. Related method used was Huffman coding and discrete wavelet transform. Huffman coding compression is a type of data compression algorithm that allows you to completely recreate the actual data from the compressed data. Huffman's algorithm is relatively simpler due to the simpler mathematical calculations used to determine various parameters. So, with involvement of digital photo restoration, the original image can be reconstructed. In general, Huffman coding applies the concept of a binary tree which develops binary data based on the input image data. This technique is very efficient in minimizing code redundancy by using binary data to represent the input data. Discrete wavelet transform (DWT) can be used in most cases to convert a discrete time sign right into a discrete wavelet representation. Discrete wavelet transform is generally based on a timeline display that can provide multiple resolutions. In fact, DWT is a signal decomposition technique that is efficient at breaking down signals. Based on figure, the input image data is divided into four parts which are approximate LL, horizontal HL, vertical LH, and diagonal HH. The only data used for decompression process is LL, while other three parts are removed, which cause the loss of data in DWT technique. Compression performance. The compression performance is evaluated using two metrics, which is compression ratio and speed of compression. Compression ratio. The compression ratio is calculated by dividing the bit rate necessary to display the image before compression by the number of bits required to portray the same image after compression. Speed of compression. Compression and decompression duration are the essential metrics can be testing the method of image compression. The time required for the algorithm to perform the encoding and decoding algorithm is referred to as time. Image quality. Image quality is evaluated based on two metrics, which is peak signal to noise ratio and mean structural similarity index. Peak signal to noise ratio. It is frequently used as a quality matrix between the actual image and the compressed image. The better the quality of the compressed or reconstructed picture, the higher the PSNR. Mean Structural Similarity Index. The Mean Structural Similarity Index is a quality tool used to evaluate the overall picture quality in between actual image and the decompressed image. Discussion. Rahman and Hamada in 2019 have detailed study of various standard lossless picture compression methods like Shannon-Fano, run-length, LZW, Huffman coding, and arithmetic coding. Using a common numerical dataset, all of the algorithms state were discussed. They also used conventional criteria to assess the superiority of such strategies, such as decoding time, encoding time, compression ratio, average code length, and PSNR. Finally, they believe that the Huffman coding surpasses other state-of-the-art approach in real-time lossless compression applications. In other paper, the compression technique increases the capacity of the memory and increases the transfer speed. Compression encoding techniques. The image secret exchange is reduced in size. Huffman encoding compresses the image by 40%. Huffman's algorithm is comparatively easier than the absolute moment block truncation coding and the block truncation coding due to easier mathematical procedure used to determine the various parameters. Sojitra and others in 2012 has proposed an efficient embed coding method for medical image compression based on DWT. The study demonstrates the use of wavelet transforms in combination with non-sample directional filter banks. The suggest algorithm compresses data better than EZW, SPIHT, and others. Our new compression algorithm, which has been modified EZW, is a DWT based combination, and it might be applied to increase the performance of the compression ratio and the peak signal to the noise ratio. Sawane in 2018 has presented an effective scheme for e-medical data compression based on wavelet analysis. The suggest approach compresses and decompresses medical image using a DWT-based compression technique, resulting in shorter transmission times and higher data compressibility. This was accomplished by the author by lowering data storage space. As a result, the research is aimed at establishing low-cost, higher quality data compression for the analysis of various models. To ensure great efficiency, many mother wavelet types were used, including Fourier transform, DWT, HAR, and FFT. This is important due to the increased use of health monitoring systems and intelligence agency as key foundation. Reference. These are the paper I used to refer for my research paper. Conclusion. In this work, we discuss image compression algorithm based on Huffman coding and the discrete wavelet transform. From the previous research paper, we can see that Huffman coding and DWT play vital role in previous paper, which Huffman coding is give higher peak signal to noise ratio on lossless technique, higher compression and decompression speed, and no major changes on the images after decompression compared to original image. Thank you.